Hi everyone, welcome to our channel. In this video, we are exploring the amazing impact of artificial intelligence and its wide range of applications. Let's dive in. Artificial intelligence refers to the development of computer systems that can perform tasks that require human intelligence. These systems are designed to analyze vast amounts of data, learn from the patterns, and make intelligent decisions. AI can be categorized in following major types: narrow AI, artificial general intelligence, machine learning, natural language processing, robotics, computer vision, expert systems, deep learning. Narrow AI, which is also known as a weak AI or specialized AI, it can be described in following characteristics: limited scope. Narrow AI systems are designed to perform scientific tasks or solve particular problems within a well-defined domain, such as playing chess, recognizing images, or translating languages. No general intelligence. Unlike general AI, which aim to mimic human level intelligence across a broad range of domains, narrow AI lacks the ability to transfer knowledge or skills to other tasks outside its specialized area. Rule-based or data-driven. Narrow AI systems are typically built using either rule-based algorithms with predetermined rules and decision trees, or machine learning techniques that learn patterns from large datasets within their defined domain. General AI, also known as strong AI or artificial general intelligence. It is also described with following characteristics: broad capabilities. General AI systems are designed to process human level intelligence and cognitive abilities, capable of reasoning, problem solving, learning, and adapting across a wide range of domains and tasks, similar to the general intelligence exhibited by humans. Transfer learning. Unlike narrow AI, which is specialized for specific tasks, general AI aims to acquire knowledge and skills that can be transferred and applied to various domains, enabling it to tackle novel situations and problems without being explicitly programmed. Self-awareness and consciousness. A key goal of general AI is to develop systems that process self-awareness, consciousness, and the ability to understand, reason about their own thoughts and emotions, similar to the subjective experience of the human beings. Here are some common applications that you might be familiar with. Virtual assistants. AI-powered virtual assistants like Siri, Alexa, and Google Assistant can respond to the voice commands, answer questions, and perform tasks, making our lives more convenient. Natural language processing AI enables machine understandable things. AI can also adapt in educational content to individual students' needs, providing personalized lessons and feedback to enhance their learning experience. There are so many other applications of AI with these types. Thank you. Hey everyone, welcome back to our channel. Today we will discuss about artificial intelligence, machine learning, and deep learning. Let's start. Artificial intelligence. Artificial intelligence is the simulation of human intelligence processed by machines, especially computer systems. These processes include learning, reasoning, problem solving, perception, and decision making. For example, Siri. Siri is an example of artificial intelligence, providing a visual personal assistant that responds to the voice commands, performs tasks, and offers recommendations based on the user input. Alexa. Alexa is an AI-powered virtual assistant developed by Amazon, capable of voice interaction, music playback, making to-do lists, setting alarms, providing weather, traffic, sports, and other real-time information. Machine learning. Machine learning is the artificial intelligence subset enabling computers to learn from data and enhance performance without explicit programming. For example, spam filtering. Spam filtering machine learning techniques used to automatically classify emails as spam or non-spam based on patterns learned from labeled data. Recommendation systems. Recommendation systems, machine learning algorithms that analyze user preferences and behaviors to provide personalized suggestions for products, movie, music, or content. Deep learning. Deep learning is a subset of machine learning that employs artificial neural networks with multiple layers to extract hierarchical representations of data aiming to mimic the structure and functions of the human brain. For example, image recognition. Image recognition deep learning models like co-evolutional neural networks can accurately classify and identify objects or features within image. Natural language processing deep learning models such as recurrent neural networks or transformers are used for tasks like language translation, sentiment analysis, and text generation. Machine learning and deep learnings are interconnected with AI. Thank you so much. Hey everyone, welcome back to our channel. Today discussion on the detailed concept of machine learning. In our increasingly digital world, understanding the complication of machine learning is paramount. Let's dive into the core concepts and applications of this transformative technology. Machine learning, a subset of artificial intelligence, empowers computers to learn from data without being explicitly programmed. It's the driving force behind many innovations we encounter daily, from personalized recommendations to autonomous vehicles. Types of the machine learning algorithms. Supervised learning algorithms learn from labeled data with input-output pairs to make predictions or classifications. Unsupervised learning algorithms find patterns, structures in unlabeled data. Reinforcement learning algorithms learn to make decisions through trial and error, receiving feedback in the form of rewards or penalties. Daily life applications of machine learning. Personalized recommendations. Recommendation systems analyze user behavior and preferences to suggest relevant items or content. Virtual assistant systems like Siri, Alexa, or Google Assistant utilize NLP and machine learning to understand and respond to user queries. Health machine learning aids in diagnosis diseases, predicting patient outcomes, and optimizing. Treatment plans. Finance application includes the fraud detection, risk assessment, and algorithmic trading. Transportation, autonomous vehicles, traffic management, and road optimization benefits from machine learning technologies. Challenges and ethical considerations. Bias and fairness. Machine learning models may reflect biases present in training data, leading to unfair outcomes. Privacy collection and analysis of personal data raise privacy issues and data security risk. Accountability and transparency. Lack of understanding of how algorithms make decisions can lead to mistrust and ethical dilemmas. Hey everyone, welcome back to our channel. Today we are diving into a fascinating world of machine learning, specifically focusing on the two main types, supervised and unsupervised learning. But before we jump into that, let's grasp what machine learning is all about. Machine learning is all about us. From Siri understanding our questions to predicting our shopping preferences, it's the process of teaching machines to learn from data without explicit programming. Take Siri, for instance. When you ask a question, a speech recognition system algorithm converts your words into text, which is then analyzed to understand your intent. This is the essence of machine learning. Supervised learning. As that name suggests, words under supervision. In this method, machines are trained with labeled data. Labeled data means data where we already know the answers. For example, if I show you an image of a dog and I tell you it's a dog, that's labeled data. We feed this labeled data into the machine and it learns to associate features with labels. So when you understand data comes into the machine can accurately predict and make decisions based on past data text. Supervised learning can be further divided into two categories: classification and regression. Classification. Classification is used when the output variable is categorized, like determining if an email is spam or not. For example, to determine if an email is spam, we use various filters like analyzing content, email headers, and keywords. These filters give the email a spam score, and based on this score, the algorithm decides whether it goes to the inbox or the spam folder. Regression, on the other hand, deals with predicting continuous values. For instance, we can predict humidity based on temperature. After training the machine with data on temperature and humidity, it can accurately predict humidity for a given temperature. Now let's explore some real-life applications of supervised learning. First, risk assessment in financial services uses supervised learning to minimize risk. Portfolios image classification, like Facebook recognizing faces in photos, is another example. Fraud detection, where machines identify fraudulent transactions, and visual recognition, where objects and images are identified, are also common applications. Unsupervised learning. There is no labeled data, and the machine tries to identify patterns on its own. Clustering and association are the two main types of unsupervised learning. Clustering groups data based on similarities. Imagine a telecom company trying to reduce the churn rate. They analyze customer behavior based on a call duration and internet usage, and then group customers accordingly. By understanding these patterns, they can offer tailored plans to retain the customers. Association finds the relationship between variables in large data sets. For instance, consider a supermarket analyzing customer purchases. If customer 1 buys bread and milk and customer 2 buys bread and rice, it's highly likely that the customer 3 who buys bread will also buy milk. This association helps in making recommendations and improving the sales. Thank you once again.
Hey everyone, welcome back to our channel. Today we will dive deep into the linear regression, understanding its theory, applications, and even a practical use case. Let's begin. Linear regression is a powerful tool, especially in scenarios like profit estimation for companies. Imagine you are an investor and you want to know the profit potential for a company. We will take a simple example of predicting profit based on research and development expenditure. By analyzing how much a company invests in R&D and its resulting profit, we can make informed investment decisions. To understand the linear regression better, let's start with the basics of the machine learning. In machine learning, we deal with various algorithms categorized into supervised, unsupervised, and reinforcement learning. Today we are focusing on supervised learning, especially regression. Let's see how linear regression fits in. Linear regression is a technique used to predict the relationship between independent and dependent variables. An independent variable denotes as X doesn't change due to other variables, effects like rainfall. In contrast, a dependent variable denotes as Y changes based on the independent variable like crop yield. Before we delve deep, let's distinguish between numerical and categorical data. Numerical data involves numbers like age or salary, while categorical data involves descriptions like color or gender. In supervised learning, we already have labeled data and we use it to train our models. Regression, a subset of supervised learning, aims to predict continuous values within regression to gather a different type like simpler linear, multiple linear, and polynomial linear regression. Simple linear regression. It involves drawing a straight line through data points to predict the relationship between the variables. Let's take our rainfall and crop yield example again. We plot the data and draw a linear line that through it. This linear helps predict crop yield based on real rainfall. Now let's look at applications of linear regressions. It's used in various fields like economics, predicting product prices, housing sales, and even sports score predictions. For instance, it can help estimate a country's economic growth on forecast the price of a product. Now let's understand the theory behind linear regression. It's all about finding the most accurate line that predicts the relationship between variables. We use basic formula y is equal to mx plus c,
where y is the dependent variable, x is the independent variable, m is the slope, and c is the intercept.
To calculate the regression line, we use equation geometry, finding the slope and intercept. The slope indicates how much the dependent variable changes for a unit change in the independent variable. The intercept represents where the line crosses the y-axis. To make things clearer, let's consider a simple data set. We take 5 data points and plot them. Then we calculate the means of x and y, which represents the average values. Plotting these means help us drawing line through the data, given us a good estimate. Thanks for watching the video.
Hey everyone, welcome back to our channel. In this video, we are diving deep into logistic regression, a fundamental concept in machine learning. Logistic regression. It is a statistical technique used for binary classification tasks. For example, predicting whether an email is spam or not, or whether a customer will churn or not. Logistic regression in Python. Logistic regression in Python refers to implementation of the logistic regression algorithm using Python programming language, often leveraging libraries such as scikit-learn, TensorFlow, PyTorch. It involves predicting the probability of a binary outcome, such as yes or no, spam or not spam, based on input features. Code snippets demonstrating implementation using scikit-learn. Mathematical behind logistic regression. To truly grasp logistic regression, it's important to understand the mathematics behind it. The logistic function, also known as the sigmoid function, transforms the output into probabilities between 0 and 1. Example. Let's consider an example predicting whether a student gets admitted to a university based on their CGPA and test score. By applying logistic regression to this data, we can create a decision boundary to classify students into admitted or not admitted. Once we have built our model, how do we know if it's any good? These matrices help us assess the performance of our model and make improvements if necessary. Relation to other machine learning algorithms. Logistic regression is just one piece of the machine learning puzzles. It's often used alongside other algorithms like decision trees, random forests, and neural networks to build more complex models. Thanks for watching the video.
Hey everyone, welcome back to our channel. In this video, we will explore the concept of the decision trees. What is the decision tree? What are the problems a decision tree solves? What are the advantages of the decision tree? What are the disadvantages of the decision tree? How does decision tree works? What is a decision tree? It's a tree-shaped diagram used to determine a course of action. Each branch represents a possible decision occurrence on reaction. Let's take a simple example to understand it better. How do I identify a random vegetable from shopping bag? We start by asking a question. Is it red? If not, it's probably an eggplant. If true, we ask another question. Is the diameter greater than 2? If false, it's a red chili. If true, it's a bell pepper. This simple flowchart helps us make decisions based on given criteria. Decision trees can solve various problems. They can be used for classification, where we classify data into categories like true, false, and yes/no classification. We use logical if-then conditions to classify problems. For example, discriminating between types of flowers based on features. Regression, where we predict numerical values fitting the model to the target variable using independent variables. Each split is made based on the sum of squared errors. For example, house price prediction. Now let's explore the advantages of the decision trees. They require little effort for data preparation, handle both numerical and categorical data, and can handle non-linear parameters effectively. However, decision trees also have disadvantages. They can suffer from overfitting, where the model captures noise in the data, leading to low generalization. They can also have high variance and low bias, making them sensitive to small variations in the data. Now let's understand some key terms. Entropy measures the randomness or unpredictability in a dataset. Information gain is the measure of decrease in the entropy after splitting the dataset. Decision trees consist of leaf nodes, decision nodes, and root nodes. Now let's see how decision trees work in practice. Imagine we want to classify different types of animals based on their features using a decision tree. We start with a messy dataset and aim to split it in such a way that entropy decreases. We calculate entropy for the current dataset and then calculate the gain for each possible split. We choose the conditions that gives us the highest gain. For example, in our dataset, we first split based on the color yellow. Then we split the further based on height unit. Each branch contains a single label type. This tree can now predict all classes of animals present in the dataset with 100% accuracy. Decision trees offers visual and intuitive way to make decisions based on given criteria. That's all for today. Thanks. Hey everyone, welcome back to our channel. Welcome to our exploration of K nearest neighbors KNN algorithm. Today we will delve into KNN, a fundamental concept in machine learning. KNN is a simple, powerful algorithm used for classification and regression tasks. Let's uncover its key aspects. Why do we need KNN? What is KNN? How do we choose the factor K? When do we use KNN? And how does the KNN algorithm work? To start with, imagine you are a young child learning to differentiate between cats and dogs. You can do this by observing their similarly. Cats have shaped claws, smaller ears, and meow, while dogs have dull claws, larger ears, and bark. Similarly, KNN classifies data based on features similarly. If we have a new picture, we compare its features with those of known pictures of cats and dogs to determine its classification. Now, let's talk about the KNN algorithm. KNN stands for K nearest neighbors. It classifies a data point based on the classification of its nearest neighbors. The permanent K refers to the number of neighbors considered. Choosing their right K value is crucial. Too low and it might overfit the data. Too high and it might underfit height and a fit. Typically, the square root of a total number of data points is used as K, and it's often made odd to avoid ties. KNN is suitable for labeled data, small data sets, and when the data is noise free, it's not ideal for large and complex data sets due to its lazy learner nature. Imagine we have data on height and weight, and we want to classify individuals as normal or underweight. We calculate the Euclidean distance between the unknown point and all other points. Then we select the K nearest neighbors based on the shortest distance. The majority class among these neighbors determine the classification of the unknown point. It's like taking a vote among the neighbors. That concludes our journey into the K-means neighbors algorithm. We have covered its basics, applications, and how it works. That's for the joining us today. Welcome back to the Core Hub. My name is Dr. Fakir Kazmi, and today we are going to discuss Random Forest, a powerful tool in the machine learning library. In this video, we will discuss applications of Random Forest, what is the Random Forest, why use Random Forest, how to use Random Forest. Let's dive in. Applications of the Random Forest. Before we get into what Random Forest is, let's look at some of its applications. Spam detection. Random Forest is widely used for classifying emails as spam or not spam. It analyzes patterns in emails to filter out unwanted messages. Healthcare. It helps predict disease outbreaks and patient outcomes by analyzing the medical records and symptoms. Finance. It's critical in detecting fraudulent transactions, analyzing spending patterns to identify unusual activities. Remote sensing. Random Forest is used in satellite imagery to classify different land covers and monitor environmental changes. These applications showcase the versatility and power of Random Forest in solving complex problems. What is Random Forest? Now let's understand what Random Forest is. Random Forest is an ensemble learning method that operates by constructing multiple decision trees during training. The final decision is based on majority. How does Random Forest work? Here is how it works. Data splitting. The data set is split into several smaller sets. Decision tree. Each subset is used to train a different decision tree. The trees are limited on random subsets of the data and use random subsets of features. Voting. Each tree votes on the classification. The majority vote is taken as the final decision. Example: spam detection. Let's illustrate this with an example of classifying emails as spam or not spam. Imagine you have an email dataset. A single decision tree might look at the presence of certain keywords to classify emails. For instance, is free in the subject line? Yes, likely spam. No, move to the next. Check. Does the email contain a link? Yes, likely spam. No, move to the next step. In Random Forest, multiple such decision trees are created. For example, tree 1 classifies an email as spam. Tree 2 classifies the same email is not spam. Tree 3 classifies it is as spam. The Random Forest algorithm will take the majority vote, which is in this case is spam. Why use random forest? Why use random forest over other algorithms? Here are some key advantages. No overfitting. By using multiple trees, random forest reduces the risk of overfitting. High accuracy. It produces highly accurate predictions, especially with large data sets. Handles missing data. It can maintain accuracy even when a large proportion of the data is missing. Scalability. It runs efficiently on large databases, making it ideal for big data applications. In summary, the random forest is a powerful and versatile tool in machine learning, offering a high accuracy and robustness of overfitting and missing data. Whether you are classifying emails or predicting patient outcomes, random forest can be a valuable part of your toolkit. Thank you for joining us today.
Welcome back to the Core Hub. My name is Dr. Faqat Kazmi, and today we will discuss about support vector machines. Let's look at its common applications. Applications of support vector machine. SVM is widely used in various fields such as face detection, text and hypertext categorization, image classification, and bioinformatics. These are just a few examples. As we go through this lesson, think about other possible applications. Today, we will cover the following key sections. Number 1. What is machine learning? Why is support vector machine? What is a support vector machine? Understanding the support vector machine. Advantages of the support vector machine. A real-world use case. What is machine learning? Machine learning can be divided into three main categories: supervised learning, unsupervised learning, and reinforcement learning. SVM falls under supervised learning, where we train the model with labeled data and make further predictions. Why the support vector machines? SVM is primarily used for classification problems. For instance, imagine trying to classify fruits as strawberries or apples. We provide the model with labeled data for strawberries and apples, and once trained, the model can identify a new fruit as either a strawberry or an apple. What is the support vector machine? SVM is a supervised learning method that sorts data into two categories. By finding the optimal boundary or hyperplane, SVM maximizes the margin between different classes. This margin helps in making accurate predictions. Understanding the SVM with an example. Consider a simple example of classifying men and women based on height and weight. We plot this data and draw lines to separate the two classes. The optimal hyperplane is the one that maximum the margin between the two classes. This ensures that new data points are classified correctly. Advanced SVM concepts. In more complex scenarios where the data is not linearly sparsable, we use kernel functions. Kernels transform data into high dimensions, making it easier to find a sparsing hyperplane. This allows SVM to handle intricate classification tasks effectively. Advantages of SVM. Number 1. High dimensional space. SVM works efficiently in high dimensional spaces. Number 2. Effective with sparse data. It performs well with sparse document vectors. Number 3. Regularization parameters. SVM avoids overfitting and bias issues, making it a robust algorithm for various applications. Real-world case. Imagine using SVM at a zoo to differentiate between crocodile and alligators. By training the model with labeled data based on features like size and sonnet,
width, SVM can accurately classifying new observations. This is just one example of how SVM can be applied in practical scenarios. Welcome back to our channel. Today we discuss naive-Bayes classifier tutorial. Have you ever wondered how your email provider filters spam or how news channels classify the articles? These tasks are accomplished using a machine learning algorithm called the naive-Bayes algorithm. Welcome to the Core Hub. I am Dr. Faqat Kazmi. In this tutorial, we will cover the following. What is naive-Bayes? How does it work? Naive-Bayes in machine learning. Advantages of the naive-Bayes classifier. What is naive-Bayes? The naive-Bayes classifier is based on the Bayes theorem, which provides a way to calculate the probability of a hypothesis given prior knowledge. It works on the principle of conditional probability. Named after the revered Thomas Bayes, this theorem has become a cornerstone in the field of statistics and machine learning. Basic probability concepts. Before diving into the naive-Bayes, let's review some basic probability concepts. Probability measure the likelihood that an event will occur. For example, the probability of getting heads when tossing a coin is 1/2. In the context of naive-Bayes, we use these probability measures to make predictions based on given data. Bayes theorem. Bayes theorem states the probability of A given B is equal to the probability of B given A multiplied by the probability of A divided by the probability of B. This formula calculates the probability of event A occurring given event B has occurred. This is crucial in updating our predictions based on new evidence. Naive-Bayes in machine learning. Naive-Bayes is a supervised learning algorithm used for classification tasks. It is particularly useful for text classification problems such as spam detection, sentiment analysis, and news classification. Despite the simplicity, naive-Bayes can perform surprisingly well in these contexts, making it a valuable tool in the data science toolkit. Advantages of the naive-Bayes classifier. Number 1. Simplicity. Unlike more complex algorithms, naive-Bayes is straightforward to implement. Its simplicity makes it easy to interpret and explain. Number 2. Efficiency. Naive-Bayes is computationally efficient. It can handle large amount of data with minimal processing time. Number 3. Performance. Naive-Bayes often outperforms more complex models, especially in text classification problems. Its robustness and reliability are well documented in various studies. Real-world applications. Naive-Bayes classifications are widely used across different domains. Number 1. Email spam filtering. Classifies email as spam or not spam. Number 2. Sentiment analysis. Determines whether a piece of text expresses positive, negative, or neutral sentiments. Number 3. News classification. Categorizes news articles into different topics such as sports, politics, or technology. Medical diagnosis. Assist in diagnosis diseases by analyzing patient symptoms and medical data. Each of these applications demonstrates the versatility and power of the naive-Bayes classification in solving real-world problems efficiently. Conclusion. The naive-Bayes classification is a powerful tool for probabilistic prediction, especially in text classification tasks. Its simplicity and efficiency make it a popular choice in machine learning. Understanding how it works and its applications can greatly benefit anyone interested in data science and machine learning.
Thank you for joining this video. Hello and welcome to this session of K-means clustering. I am Dr. Fakat Kazmi from Core Hub. Today we will explore what K-means clustering is and how it works. K-mean clustering is an unsupervised learning algorithm used to group a set of data into clusters based on their similarities. Unlike supervised learning, you don't have labeled data. Instead, you want to identify inherent grouping in your data. For example, if k is equal to 2, the data will be grouped into 2 clusters. If k is equal to 3 clusters, and so on. Determining the optimal number of clusters is part of the process we will explore. Example: cricket players. Let's take a practical example using cricket. Suppose we have data on cricket players that includes the number of runs scored by the number of wickets taken by each player. We want to cluster these players into 2 groups, batsmen and bowlers. Batsmen generally score more runs while bowlers take more wickets. There will be some overlap, such as bowlers who score runs and batsmen who take wickets. But our goal is to cluster them based on their primary roles. How K-mean clustering works? Number 1. Initialization. The first step is to allocate k centroids randomly. For k is equal to 2 points are assigned as initial centroids. Number 2. Assigning data points. Each data point is then assigned to the nearest centroid. The distance between each data point and centroids is calculated and the point is assigned to the closest one. Recomputing centroids. Once all points are assigned, the centroids are recalculated as the mean of the points in each cluster. Number 4. Iterating the process. Steps 2 and 3 are repeated until the centroids no longer change significantly. This indicates the clusters are stable and the algorithm has converged. Types of clustering. Clustering techniques can be broadly categorized into: Number 1. Hierarchical clustering. Agglomerative. A bottom-up approach where each data point starts as individual cluster and merges into large clusters. Divisive. A top-down approach that starts with one cluster and divides it into smaller clusters. Number 2. Partitional clustering. K-mean clustering divides data into k clusters based on similarity. Fuzzy C-mean clustering, similar to k-means but allow data points to belong to multiple clusters. Applications of K-mean clustering. K-means clustering is widely used in various fields such as academic performance, categorizing students based on their scores, search engines, grouping search results for better relevance, wireless sensor networks, identifying cluster heads to collect data, distance measures. Distance measures are crucial in K-mean clustering to determine the similarity between data points. Common distance measures include Euclidean distance, Manhattan distance, squared Euclidean distance. Thank you so much. Hello and welcome to Core Hub. I'm Dr. Fakat Kazmi. Today we are diving into the fantastic world of hierarchical clusters. Let's get started. What is clustering? Clustering is the process of grouping objects that are similar to each other. It's widely used in areas like customer segmentation, social network analysis, and city planning. For example, if you are planning a trip to 20 places in 4 days, you can use clustering to group nearby locations together, making your travel more efficient. Types of clustering. There are 2 main types of clustering, hierarchical and partitional. Hierarchical clustering. Hierarchical clustering forms a tree-like structure called dendrogram. while partitional clustering like k-means divides data into performed clusters without a hierarchy. In hierarchical clustering, we have two approaches, agglomerative and divisive. Agglomerative clustering starts with individual elements and merges them into clusters bottom up, whereas divisive clustering starts with one large cluster and split into smaller one top down. How hierarchical clustering works? Hierarchical clustering separates data based on similarity. For instance, if we have a set of cars, we could first group them into sedans and SUVs and then combine them into one cluster. Agglomerative clustering. Agglomerative clustering begins with each data point as its own cluster. We then merge them to closest cluster step by step until only one cluster remains. Divisive clustering. Divisive clustering starts with one large cluster and splits it until each data point is its own cluster. Measuring distance. To group data points accurately, we need to measure the distance between them. Common distance measures include Euclidean distance, the straight line between 2 points. Squared Euclidean distance, like Euclidean but without taking the square root, simplifying calculations. Manhattan distance, the sum of the absolute differences of their coordinates. Cosine distance, measure the angle between two vectors, useful for high dimensional data. Clustering process. Here is the process for hierarchical clustering. Number 1. Start with individual clusters. Each point is its own cluster. Number 2. Measure distance. Use one of the distance measures to calculate the proximity of clusters. Number 3. Merge closest clusters. Combine the closest clusters step by step. Number 4. From dendrogram, visualize the merging process in a tree structure. Number 5. Terminate, when only one cluster remains, are based on a predefined condition. Practical applications. Hierarchical clustering is essential for customer segmentation, social network analysis, and city planning. It helps processes data for data models and discover hidden patterns. Thank you for joining me on this journey through hierarchical clustering. Hello and welcome to Core Hub. I'm Dr. Faqat Kazmi, and today we will dive into the fantastic world of the time series analysis and forecasting. What time series analysis? Time series analysis is crucial when we want to predict future values based on past data. It's commonly used for forecasting stock prices, sales figures, interest rates, and more. Unlike general machine learning predictions, time series forecasting specifically deals with temporal data, allowing us to make informed predictions about the future. Understanding time series data. Time series data consists of observations recorded at specific time intervals. These intervals can vary from milliseconds in sensor data to daily stock prices. The data is plotted with time on the x-axis and the observed values on the y-axis. Components of time series data. Number 1. Trend. The overall direction of the data over time. It shows whether the data is increasing or decreasing. For example, stock prices might show a long-term upward trend. Number 2. Seasonality. Predict fluctuations that occur at regular intervals such as daily, monthly, or yearly. An example is the increase in sales of warm clothes every winter. Number 3. Cyclicity. Similar to seasonality but occurs over longer, irregular intervals. Economic recessions are a typical example, occurring every few years without a fixed pattern. Irregularity, random component. Random unpredictable variations that cannot be attributed to trend. Seasonability or cyclicity, these are random fluctuations in the data. Stationary data. For effective time series analysis, the data should be stationary, meaning its statistical properties like mean and variance are constant over time. Most time series data is not stationary, but it can be transformed into stationary data through techniques like differencing and detrending. In this video, we covered the basics of time series forecasting and its components: trend, seasonability, cyclicity, and irregularity. Understanding these concepts is essential for accurate predictions. Hello and welcome to Core Hub. I'm Dr. Faqat Kazmi, and today we are going to dive into the fascinating world of deep learning. Ever wondered how Google Translate an entire web page in seconds, or how your phone gallery groups images by location? That's all thanks to deep learning. So, what exactly is deep learning? Let's find out. What is deep learning? Deep learning is a subset of machine learning, which is itself a subset of artificial intelligence. AI enables machines to mimic human behavior. Machine learning achieves AI through algorithms trained with data. Deep learning, inspired by the structure of the human brain, uses artificial neural networks to achieve machine learning. Deep learning versus machine learning. To understand deep learning better, let's compare it to machine learning. Suppose we create a machine to differentiate between tomatoes and cherries. With machine learning, we had manually specify features like size and stem type. With deep learning, the neural network autonomously picks out these features without human intervention. Through it requires a much higher volume of data for training. How neural networks works? Let's explore how neural networks function. Imagine 3 students each writing the digit 9 on paper. The human brain can easily recognize these digits, but for a computer, this task requires deep learning. A neural network trained to identify the handwritten digits works as follows. Number 1. Each digit is represented as a 28 by 28 pixel image. Total 784 pixels. Number 2. Each pixel is fed to a neuron in the input layer of the neural network. Number 3. The network has an input layer, hidden layers, and an output layer. Each neuron in the output layer represents a digit. Number 4. Information travels through connecting channels, each with an associated value or weight. Number 5. Neurons. Neurons have a bias value added to the weight sum of inputs, which is then processed by an activation function. Number 6. Activated neurons pass information to sequential layers until the output layer identifies the digit. Weights and biases are continuously adjusted to create a well-trained network. Applications of deep learning. Deep learning is applied in various fields. Number 1. Customer support. Chatbots simulates real conversations with customers. Number 2. Medical care. Neural networks detect cancer cells and analyze MRI images. Number 3. Self-driving cars. Companies like Apple, Tesla, and Nissan are developing autonomous vehicles. Limitations of deep learning. Despite its vast potential, deep learning has limitations. Number 1. Data requirements. Neural networks require massive volumes of data for training. Number 2. Computational power. Training requires graphical processing units, GPUs, which are costly and have thousands of cores compared to central processing units, CPUs. Number 3. Training time. Deep neural networks can take hours or even months to train, increasing with data volume and network complexity. Conclusion. Some popular deep learning frameworks include TensorFlow, PyTorch, Keras, Deep Learning 4J, Caffe, and Microsoft Cognitive Toolkit. The future of deep learning and AI holds immense potential. Innovations like a device using deep learning to assist the blind show we have only scratched the surface. Thank you for watching.